Alright, so this is the beginning of Unit 1 for 9th grade, or Secondary Math 1. And to start, for our first section, we're going to be talking about multi-step equations and how to solve them. Okay, now below we have a series or an order that we need to go in to be able to solve any of our equations. The first one is going to be using the distributive property to clear all parentheses. The second is to combine like terms on each side of the equal sign. The third is to get all variables on one side of the equal sign. The fourth, get all constants or numbers on the other side of the equal sign, and then solve for the variable. Okay, now we're going to walk you through this kind of slow, but bear with us. If you need to skip ahead in the video so it makes it a little bit easier, you're more than welcome to. Okay, so if we start here on number 1 and we look at our very first step that we need to use, it says to use the distributive property to clear all parentheses. Now if you can remember, the distributive property is what we're going to multiply to get rid of our parentheses. We always want to start off by getting rid of those. Okay, and when we distribute, we're basically saying this 3 is going to multiply by our r and by our negative 4 over here. Okay, so when we do this, we get a 3 times an r, which is just going to be 3r, and 3 times a minus 4, which should just be minus 12, equals 9. Okay, now it says combine like terms on each side of the equal sign. Now currently there are no unlike terms on other sides, so now we need to get all variables on one side of the equal sign. Our r, which is our variable, is the only r, so we've already done that. Now we need to get all constants on the other side of the equal sign. Now a constant in this case would be this minus 12. To move it, we want to do the opposite, add it over, okay, and get our next step in the equation. Now the negative 12 plus 12 will give us 0, so it'll cancel for us, and we're left with 3r equals 9 plus 12, which is 21. Okay, from here we need to understand that the 3 here is multiplying by r, so we need to divide off that 3, or do the opposite as a multiplication, to get our answer, which is 21 divided by 3, or 7. That's our answer. Okay? So, let's move on to number 2. Now number 2 is a little bit more complicated, but equally so. We still have to follow the same steps that we did on 1 to make sure that we get the right answer. Okay? So, for number 2, let's start out here. 3y is not doing anything currently, and our first step probably is going to be to get rid of these parentheses. Use the distributive property to clear all parentheses as our first step. So, what does that look like? Well, make sure you draw your lines. Okay? You should get a minus 2 times 3. Now a negative 2 times 3 is going to be a negative 6, so we're just going to write it out like that. Minus 6y, and then negative 2 plus times a negative 2 times 2 will give us that minus 4 that we're looking for here. Okay? From there, our next step is to combine like terms on each side of the equal sign. Now a like term means that we share something in common with something else on that side. You notice the 3y and the 6y are over here. We can't have two y's on the same side, so we need to get them into one single term, or one whole. So what is 3? If we're thinking about it, what is 3 minus 6? Well, that's just a negative 3. And then we have those y's just tacked on at the end. Okay? Then we minus 4, just from here, because nothing happened there, and we get equals 8. Now it's looking way more similar to our earlier problem here than this one, as this does. Okay? So my next step is going to be to add 4 to both sides. That'll get rid of those constants, just like we have to do. We said here, get all constants on the other side of the equal sign. Minus 4 plus 4, that'll give us 0, so those will cancel. We should end up with a negative 3y equals 8 plus 4, which is 12. Then you're dividing your minus 3. Those cancel, and you end up with y equals 12 divided by negative 3 is negative 4. And that's your answer. Okay? Okay, coming back to this. Let's now move on. We're not going to, you guys will still be able to view this top little part here, but I won't be. So you're going to have to be able to follow along with these steps as I say them. Okay? So, 3 is a little bit different, right? If we're looking at what our original our first step is to use the distributive property to clear parentheses. On number 1, you can see that we had a 3 that kind of came through, and on number 2, we had a negative 2 that distributed. Whereas on 3, we have no number here. How I like to think about it is that there's an imaginary 1 right there. A minus 1 if you want to think about it. So instead of distributing a minus 3, you can think of it as doing negative 1 times x and negative 1 times 6. Okay? Now, what'll happen if I do that? Well, we get 4x, and negative 1 times x will give us minus 1x, and minus 1 times 6 will give us minus 6 equals 24. Next step, as it says before, is to combine those like terms on each side of the equal sign. Like terms means that we have something in common. These both have an x, and we can't have them both on the same side. So we have to do 4 minus 1 to be able to get those x's into one term. 4 minus 1 being 3, and again you just tack on your x. Minus 6 equals 24. Okay? From there, it's just like our previous problems where we had a minus 3y minus 4 equals 8, and a 3r minus 12 equals 9. We have a variable number and a constant equals another number. We want to probably add that 6 over. Get 3x equals 30. Now, what are we left with? 3 times x equals 30. To undo multiplication, remember, it's division. 3x divided by 3, those 3's will cancel, leaving me with x equals 30 divided by 3 is 10. Okay, let's move on to the next one. On 4, what are we looking at? Our very first step, just like I've said so far in this video, is to look at the parentheses and get rid of them. Remember, draw your lines. It is helpful to remember what you're doing with them. So 6 times t, that'll be 6t, and then 6 times 7 would give us 42. Minus 20 equals 6t. Apologies there. Should be 6t, not. Okay? Now, our next step in the equation, it says to combine like terms on each side of the equal sign again. So, previously, we combined our 4x and our 1x, right? Now, we don't have the t's on the same side, but we will deal with that in a second. The first thing I want to do is do simple subtraction. 42 minus 20, okay? You want to keep, since they're on the same side, you just want to subtract them like normal. Get them into one term. 42 minus 20 is going to give us 22, a positive 22. So that's why we keep that plus right there. Okay? Our next step, it says, is to get all variables on one side of the equal sign. Now a variable is those t's right there. Those t's are your variables that we'll be looking at. Okay? In order to get them on the same side, you want to subtract them as a whole together. So my very next step is probably to get the 6t over. I like to move them to the left. It keeps everything in line for me. So I'm going to minus that 6t. Now 6t minus 6t is going to give you 0 right there. Okay? And 6t minus 6t will give me 0 as well. But I don't write 0t. Okay? Because 0 times t is already 0. Doesn't need to be there. And that 22 is just going to drop for me right down here. Now hold on a second. We're kind of running into a little bit of a conundrum here, right? 22 equals 0. But 22 is not the same number as 0. They're not equal, right? So this is called a special case. Now a special case can either be no solution or infinitely many solutions. We'll talk about infinitely many here on 5, I think, in a second. But for right now, when we have two numbers, when we end with two numbers and no letters or variables at the end, we want to call that a no solution. Okay? Now, no solution happens when we have two numbers at the end that do not equal each other, but it says they do. Okay? Since 22 and 0 are not the same, that's why it's no solution. Okay? So that's going to be our answer for this one. Or if you guys wanted to write it. Okay? All right, let's move on to these last two here. So, for number 5, it looks like a lot, okay? But take it one step at a time. Remember, it's all these steps, it's all you have to do. Your very first one, clear the parentheses. So let's clear those parentheses first. Minus 3 times 4, negative 12x, negative 3 times 7, that'll give me my negative 21, equals 6x. Now, just like we did previously with this problem, remember, that's imaginary 1's kind of sitting there. Put that there, distribute it through. Negative 1 times 2x is going to be at negative 2x. Negative 1 times 21 is minus 21. Okay? So, our very next thing that we need to be looking at here is combine our like terms. Now, like terms, remember, are things that have something in common. These x's are a common thing. Let's get those together. If I think about it, what is 16 minus 12? Well, that's just 4. And then my x's are going to tag along here. Okay? Minus 21 equals, now 6 and minus 2 is going to be the same kind of concept that we had with 16 minus 12. That's just going to give us 4x minus 21 right there. Okay? So, our next step, get all the variables on one side of the equal sign. Okay? To do that, remember, same thing that we did over here. We want to subtract one variable to the other side. So I'm going to minus the 4x here, and do the same over here. You do to one side, you must do to both. When I do that, let's see. 4x minus 4x, those will cancel and leave me with 0, right? So we're going to drop that minus 21. 4 minus 4 is going to give you 0. And we're going to drop that minus 21 as well. Okay? Now, hold on a second. If you can notice, remember what we did over here. We had something very similar. Our t's got canceled out and we were left with two numbers. But in this case, 22 equals 0 was our special case. Over here, though, we have a negative 21 equals a negative 21. We have the same two numbers that are equal to each other. This is another special case, okay? Now this special case, though, is called infinitely many solutions. Infinitely many solutions. Okay? Now, infinitely many solutions is just the same thing as IMS. And from there, you guys can see that, that's what I'm going to circle as my answer. Okay? It's when I have two numbers where all of my letters cancel out, or my variables, and I'm left with two numbers as my answer. Okay? Let's move on to 6 now as our last problem on 1.1a. Okay? For 6, again, first step, use distributive property to clear all parentheses. Okay? We're going to go 5 times x and 5 times 3, 2 times 10, and 2 times x. Okay? 5 times x is 5x, 5 times 3 is 15, plus 2x equals 2 times 10, which is 20, plus 2 times x, which is 2x. From there, you want to combine like terms. Remember, like terms are things that have things in common. 5 and 2 both have an x on them, and they're on the same side. So all I want you guys to do is think 5 plus 2. 5 plus 2 should give you 7x. Okay? Drop your 15. Equals 20 plus 2x. Now our next step is going to be get all variables on one side of the equal sign. As you can see, my 2x is over here and my 7x is over here. So what I want to do is get those on the same side. To do that, I'm going to minus this 2x. And when I minus the 2x, what happens here? Well, the 2's cancel out, and that leaves me with no x's on this side, but the x's stay over here. Okay? So 7 minus 2 would give me 5x plus 15 equals 20. From there, we need to get our numbers on the same side. So my next step is going to be minus that 15. After I minus the 15, 15 minus 15 is 0. Nothing happened to my 5x, so we're just going to drop that. And 20 minus 15 is 5. Okay? From there, a number times a variable equals a number. Divide by 5 on both sides. To undo multiplication, you always got to divide. Those 5s are going to cancel for me. That leaves me with x equals 1. Okay? I hope you followed along with it. If you have any questions, be sure to address your teacher about them.